Hi, and welcome to video 2 for section 1.2 for Math 126. This is the second of 4 videos. As I mentioned at the end of video 1, this is its own specific video because I want you to have this as a quick reference if you ever need to go back to it. And I'm telling you, I've taught 127, I've tutored people in Math 181. This is a problem for people, the idea of laws of exponents. So if we're given some numbers that have exponents, what are the manipulations we can do to them? What's allowed, what isn't allowed? And this is on page 14 and 15 in the book. You needed to follow along or you need it for reference later. The first law we have is that if I have a to the m power times a to the n power, so what do we notice here? The base is the same. The powers are different, or they could be the same, but what's important here is the base has to be the same. If the base isn't the same, I can't use this law. It's got to be the same base. When I have this, when I'm multiplying two numbers with the same base, what I will do then is I will add the exponents. So a to the m times a to the n is a to the m plus n. The second one. So that was multiplication, we ended up adding. If I have division, so a to the m over a to the n, well, this is division, so this is going to be subtraction. A to the m, the top one, minus the bottom exponent. But again, the bases have to be the same in order to use this law. Number 3. If I have a to the m power, and this whole thing is raised to the n power, so this is called the power law, a to the m to the n is a to the m times n. So now I will multiply the exponents. Here I had the same base that I was multiplying, so I added. Here there's no multiplication in here, it's just something to a power to a power. So then I'll multiply the powers together. I can use some distribution here. If I have two numbers, a times b, and it's all being raised to the n power, this is the same as if I break it apart and do the exponents separately. So a to the n power times b to the n power. Similarly, if I have a fraction inside, a over b all to the n power, I can still sort of distribute the exponent here, a to the n over b to the n. So you notice here the bases don't have to be the same, they don't have to be the same number, it's just the exponent that follows along with it. Number 6. A over b to the minus n power. So this is the one that always gets people. So this is the same. So when I had what? If I had a to the minus n earlier, this was what? It was, I take the reciprocal, right? And then make the exponent positive. So this is kind of the same as a over 1 to the minus n power. It's just instead of b, I had a 1. So this thing became what? 1 over a to the n. So this is the same as if I flip what's inside of here, 1 over a, and I make the exponent positive. And then I distribute it in, so I end up with the same thing. So if I have something, a fraction, or even just a whole number, inside a parenthesis with a negative exponent, I'm just going to flip what's inside, b over a, then make the exponent positive. And it kind of goes back to our basic one when we just had 1, but now we have 2 potential real numbers there. And then 7, if I have a to the minus m power over b to the minus n, well, if I take the value from top to bottom or bottom to top, the exponent becomes positive. So this is the same as bringing the b to the top and making it positive, taking the a to the bottom and making the m positive. So anytime you switch from numerator to denominator, you have to change the sign on the exponent. So let's say I have, I don't know, x to the negative 3 over y to the positive 2. So I always want positive exponents ideally, so I'll leave that guy alone, but I want to bring the x down, so now that becomes a positive number, leave the y alone, and what's left in top, well, it's just a 1. So if I bring something from the numerator down to the denominator, or vice versa, I have to change the sign on the exponent. And ideally, I want positive numbers in the exponents. So let's look at an example. Actually, a bunch of examples, and that's why I'll try to leave these on the board here. So if I have x to the 4th times x to the 7th. So what I would suggest is hit pause for all of these as we go through them. Use the law of exponents, see if you can get the right answer, and then hit play again and see if you're comprehending what we're talking about here. So hit pause. If you did and you're back already, great. This is what? This is law number 1. I have the same base, x, so I want to add the exponents. 4 plus 7 is 11. So this is x to the 11th power. How about y to the 4th times y to the minus 7th? And I want positive exponents here again, remember. That's what these laws do. We're trying to get positive exponents to make our life nice. So go ahead and try this one. So this one we have what? The same base, so I'm going to add the exponents. It's still law number 1. 4 minus 7 is negative 3. I don't want a negative exponent, so I have to bring it into the denominator, and that's what? That's like number 7 here. When I go from numerator to denominator, but this is like over 1. So y to the negative 3 over 1. So if I bring this down into the denominator, the exponent becomes positive, and I'm just left, this is like 1 times this guy. So I'm left with 1 in the numerator. So you should get 1 over y to the 3rd power. Number 3, c to the 9th power over c to the 5th power. So try that one. All right, this is what? This is number 2. So it's going to be c, the numerator minus the denominator. 9 minus 5 is 4. So you should have ended up with c to the 4th power. Number 4, b to the 4th all to the 5th power. So this is what? This is law number 3. So I'm now going to multiply the exponents. So this is b to the 20th power. And number 5, what if I have 3x to the 3rd power? So be careful here now. This is what? Law number 4. So be careful with what you're doing with that exponent. So I'm basically distributing this exponent, right? So this is 3 to the 3rd power. It's not 3 times 3. It's 3 to the 3rd power times x to the 3rd power. 3 to the 3rd power is what? 3 times 3 is 9, times 3 is 27. X to the 3rd power. All right, so there's some sort of straightforward examples, kind of just having to use 1 or maybe 2 laws if we needed the negative exponent to get cleared up. Let's look at some more complicated ones. Let's say I have 2 a to the 3rd b squared times 3ab to the 4th all to the 3rd power. So there's all kinds of stuff going on here, right? So go ahead, hit pause if you want, give this a shot. You're going to have a bunch of laws that you're applying. You got this exponent here you need to distribute in. Then you're going to multiply, so you got to deal with your multiplication laws. But come on back, and we'll give it a go. Try it yourself and then come on back. Welcome back. Hopefully you're able to tackle this guy. So let's kind of look at this in parts. The first one, we're not going to do anything with to start. So I'm just going to rewrite 2a to the third b squared. This one I need to distribute the 3 in. So 3 to the third is what? Well, from the last problem we saw, it's 27. This is a to the third. And this is what? B to the fourth to the third. So that's our power law. So we're multiplying those together. B to the fourth to the third gives us B to the 12th. Now it's multiplication. So I'm going to multiply the numbers, multiply the A values, multiply the B values. So 2 times 27 is 54. A to the third times a to the third, and then b squared times b to the 12th. Switch back to black, the blue doesn't write too good there. So we got 54, same base, add the exponents. 3 plus 3 is 6. Same base b, add the exponents. 2 plus 12 is 14. So your answer for this one should have been 54, a to the 6th, b to the 14th. So again, you had to use the power law first, distribute in that 3, then use multiplication and use your multiplication laws. Last example, end of this video, it's going to be 6s t to the minus 4th all over 2 s to the minus 2 t squared. So again, go ahead and give this a try. Hit pause if you need to. Come on back, see if you got it right. All right, welcome back. So we're going to look at this in 3 separate pieces. The number piece, the s's, and the t. So the first is 6 over 2. Here we have what? A division. So we're going to subtract. So this is like an invisible 1 here. We don't see any power, so that means to the first power. So the s is going to be 1 minus a negative 2. Be careful with the negative signs. And then the t portion is negative 4 minus positive 2. So if I simplify this, 6 divided by 2 is 3. S, 1 minus a negative 2 is the same as 1 plus 2. So that's the third power. And then t, negative 4 minus 2 is negative 6. But I don't want negative exponents. I want to have positive exponents. So I need to bring that down. So this is all like over 1. So if I bring that down, what's left in the numerator? 3 s to the third. And when I bring the t down, the negative 6 becomes a positive 6. So your answer should be 3 s to the third t to the positive 6. So that's the end of video 2. Come on back. We'll look at video 3 for section 1.2.